Okay, so for today's notes, we are going to be doing volume of shells and washers. We're going to do washer examples today around the y-axis this time. So this is going to be very comparable to how we did area in terms of y. It's going to have some similarities to it. So actually first, this is how you would title your notes, but then I want you to leave a little bit of space. And then this is example 1. And I actually want to start by graphing this. Okay, so if we're going to graph x equals the square root of y, that is really square both sides. That's really y equals x squared. So it looks like this. And then let's see, x equals y over 2 is really y equals 2x. Okay, so they do intersect here at y equals 4. So it would be this, okay, that we're rotating. So then I'm actually gonna, that's the bounded area, so I'm gonna clean this up. Okay, so yesterday we were talking about rotating that around the x-axis, and when we did that, it created, so if we reflect this around the x-axis, it would create this cone-like shape that's flat on the outside and curved on the inside. However, this time we're going to reflect it around the y-axis, so this time it's actually going to be curved on the outside and flat on the inside. So if you were to reflect this, got this would be circular on top. Okay, but then all of this is hollow, right? So how are we going to deal with this? Well, okay, so back to yesterday talking about these shells, which again, shells are just cylinders. They call them shells though. Shells, if we laid them the way we prefer to lay them, like this, but this one's actually going to make, this one that we're doing now is actually going to make a washer. And we talked about how yesterday with the washer, with the hollow washer, it would be the radius, the big radius squared minus the small radius squared. Well, and it's going to be that same idea here, but I want to be a little bit more specific than big radius. It's going to be whatever is on the right. So the right function, that's going to be your big radius. So I'm going to say right function. That's going to be the biggest one, the one that's furthest away from the y-axis. So right function squared minus left function squared. Okay, that's how you get your radius, and then you need pi on the outside. So pi, right squared minus left squared, and then also times the height, and this time, that's height like you prefer to see it. Height is equal to, that looks like an I. I was trying to show you the distance. That's the height, which is dy. Okay, then your limits of integration are also going to be y values. It's going to be low y value to top y value. So let's try that for this example right here. So, I solved for y so we could graph it, but we're going to have to go back to using the original ones that were given to actually do this problem. So the volume of this shape would be adding up all of the cylinders. Move the pi out front. Not cylinders. They would be washers, okay, which is like a cylinder, a hollow cylinder. Adding up all the washers from the y value 0 to the y value they intersect at 4. Okay, so then the radius of the outer function is the right function. So that would be the square root. So the square root of y squared minus y over 2 squared times, it's a parenthesis, dy. And then at this point, you can go to your calculator and plug that in. I want to do one more example together. Again, we're going to rotate this, practice this, rotating this around the y-axis. So in order to graph this one, I first need to solve for y. So if you subtract 1, then you'd have to take the square root, which means you would need plus or minus. Okay, so that's a square root, shifted 1 to the right. So it looks something like this. Okay, and then x equals 1, vertical line, like that, and y equals 2. Okay, so again, you're looking for the space that is bound by all 3 of those. Hopefully you're getting a little better at seeing that, but it almost looks like a triangle right here. And if you were to take that triangle piece and rotate it around the y-axis, what would that look like? Well, be circular on top. It would have that, it would have another, then it would have this like flat cylinder on the inside because of that x equals line, but then go up like that, so it looks something like that. Okay, that almost looks like a megaphone, kind of. Okay, so the volume of that would be, we can put that pi out front, and then we're going from the y value 0, low y value 0, to the high y value 2. And then the big radius, which would be the right function, which is the square root. But again, we're doing this in terms of y, so we're going to go ahead and do, I need parentheses, y squared plus 1 squared, because it's big radius squared, minus little radius, which is on the left, which is x equals 1, so minus 1 squared dy. And then at that point, you can plug into your calculator. And remember, when you plug this into your calculator, you do have to use x, even though it is y on your paper. Okay, once again, I have more practice problems for you to do. They're posted near this video. Again, you've got to do the work. You've got to be taking accountability for your learning here. Let me know if you have questions.